Hi, Dr. Jim Fox here. As a reminder, these videos are made in support of Dr. Stanley Pogrow's Authentic Textbook series. Links to these books can be found in the description below. In this video, I'm going to demonstrate how to run a t-test in Excel. Now, these types of demonstrations are all over the internet, but this one's going to be a little bit different. I'm going to be introducing you to a tool of authentic data analysis called a decision table. It was developed by Dr. Stanley Pogrow. So let's take a look at our data source. Under Dataset Source, you can find the full link to the public data set. It's essentially student achievement data from 2 secondary schools in Portugal. Now, this is exactly what the original data set looked like. It had a lot of different variables in it, but I was interested in the variable that they referred to as sex. It had female and males, coded M and F, and then also the math final score. And I wanted to see if there is a difference between the two groups, female and male. Now, to actually run a t-test, you need, it's easiest to run a t-test when the data is in tabular format. What do I mean by that? This is exactly what a tabular format looks like. You have the female math scores in one column and the male math scores in another column. So all I had to do was sort the sex variable column, copy the math final scores, bring them over to the female, and then go and copy the male scores. So now we're actually ready to run the analysis. Now, as a reminder, this is my research question. Is there a difference in math achievement scores between the two groups that would actually warrant an intervention? So that's what we're going to be looking at in this video. And we are going to be running a t-test because in a t-test you can compare the means of two different groups. Now, before we actually jump into the data analysis, I have a feeling you know what I'm about to say. I want to encourage you to pause the video and download the Excel data file. It can be found in the description below. If you're not sure how to do that, there's also a video that shows you how to actually download the Excel file. So you can click on that as well. Now, before we actually jump into the number crunching, I want to give you a peek at the decision-making table. And what you'll see here is that there are 3 different measures that we're going to be looking at. And this is a part of authentic data analysis. The decision-making table really involves 3 different measures. The first one is the eyeball test. That's the one that's the most common sense, simply looking at the averages between the female and the male math final scores, using our own personal judgment to make that determination. The second one, we're actually going to be calculating a p-value and we're going to be using a t-test to calculate that p-value. Now, the criteria for this is any p-values that are 0.05 or below are considered statistically significant. And in our case, with a t-test, in other words, we would say if it was below a 0.05, we would say that there is a statistically significant difference. The third measure we're going to be using is an effect size, and this just tells us how big is that difference. And we want to see a Cohen's d. That's the effect size that we're going to be using, and that's what we use for a t-test. We want to see approximately a 0.5 or above, really to say that there is some sort of difference between the two groups. So now that you've been introduced to the decision-making table, it's time to put it to work. And the very first test we're going to run is the eyeball test. And this is simply taking a look at the difference between the two averages or the two mean math final scores between the two groups, female and male. Now, I want to show you a real quick shortcut that is super handy. And it probably you may have seen it, but didn't maybe realize exactly what it was. Right at the top left up here, you see where it says A1? That's because my cursor right there is in A1. That means it's at the intersection of column A and row 1. If I were to bring it down here to this column A, row 3, this name box would change to A3. So it simply names whatever cell that you're in. Now, if I wanted to name a group of cells together, all I have to do is highlight them, go up to the name box and just type in whatever name I want. I'll just call this one Fox and hit enter. So now if I click on individual cells, they'll still be the individual cells. But if I highlight a group of cells, it turns it into an array called, I named it Fox. So we're going to do that with our math final scores. We're going to create an array of all the data that's in the math final scores female, all the numbers. We're going to group them together in an array and call them F. And we're going to group all of the male scores together in an array and call that an M. So all I have to do is go right up to the very first data point, hit Shift, Control, and then my down arrow. That's another real quick handy shortcut. We could either actually highlight all the data this way and just keep on going until the end, or simply click on the very first one, hold down Shift and Control, and then hit the down arrow. And what that does, it just goes and grabs all that data in that column that is adjacent to one another. We'll go all the way back up to the top. Now realize our data is still all highlighted, and the name box says B16. It's actually referring just to the first cell in the array, but we've highlighted all of the numbers there. I'm going to click up here and then change this to an F. That means this is all of our female data. And then hit enter. Okay, so now we've created an array of data made up of the female math final scores, and the array is named F. We're going to do the same thing with the male. Click on the very first data point in the male column, hold down Shift, Control, and then the down arrow. Again, it goes and gets all of that data in that column. I still have it highlighted, but I'm going to go right up to the name box, click one time, and then in this case, I'm going to turn that array into the name M for male, and then hit enter. Okay, so I've just named our two arrays. Now, why does this come in handy? Because we can actually use formulas and we can insert arrays. So I'm going to click in this box right here. This will represent our female math final scores average, the mean or the average. And we're going to use a function. Here's another little button that you may or may not have seen before, the little FX. And if I hover over it, it simply means insert a function here in this cell. Insert a function right in there. And we're going to insert the function called average. That means the mean. You can also find this insert function button in the formulas and right there on the left, insert function. But I'm going to use the shortcut FX. When I click on it, now in this box, we can initially search for a function. If you don't see it here in one of the common ones that you normally use, and I have all the ones that I normally use right there. I most recently used average, t-test, standard deviation, so forth. But if it doesn't show up in your box, simply start typing average and then hit enter or click go, and it will bring it right up to the top here. You can select other categories as well. You can also find it in the statistical category. Oh, there it is right there. So whenever you have it highlighted, simply click on OK. And it's asking for the group of numbers that you want to find the average of. And so you see how all of these numbers, let's just get rid of them. And all we need to type in is the name of the array. And remember what we named it? F. All I did is type F, and you can see here, it gives you a little preview. 6, 6, 10, 15. Yep, there it is. 6, 6, 10. That's the name of the array. And I'm going to click OK. And what that does, it brings the calculation, the average calculation, right into that cell. I'm going to center it up, make it a little bit prettier, and just knock it down to a tenth. 9.9 is our female average math final score. we're going to do the same thing with the male. So remember, all I have to do is click on the cell, go up to the insert function, click on average. I double clicked that time, it brought it right up. Instead of E16, this time I want to type in M. And it gives us a little preview. 15, 11, 19, 15, 11. Yep, that's it. Click OK. Again, I'm going to center this up, make it a little bit more presentable. And now we know that our math final scores for our male, the average for the males is 10.9. So this is our first analysis, the eyeball test. And all I have to do is type in 9.9 versus 10.9. So this is our first test, the eyeball test. Now, I'm going to pause the video right here, and I want to encourage you to pause the video as well. I want you to go and name the arrays F and M all the way down, change the name, and then go right here to the female average and use your fx, the insert function, average F, and then click right here and then put your result in, just like I've done. So go ahead and recreate what I've just done. And then we'll move on to the second measure, our second type of analysis, our t-test. Okay, let's move on to our second test in our decision-making table. And this sounds real complicated, but it's fairly straightforward. So what we're calculating is the p-value based upon our statistical test that we're calling a t-test. It's called a t-test, and it's simply trying to determine if there's a difference, there's a statistically significant difference between two groups. So the statistical significance refers to the p-value, and our criteria is it's equal to or less than 0.05 for us to be able to say that there is a statistically significant difference. But the statistical results are based on the actual test, the t-test. Okay, anyhow, I'd like to make this much more complicated than what it is, but all we have to do is go up to our fx, our insert function button, and then start typing in t-test and hit enter. What does it bring up? It brings up t-test. And then I'm going to click OK. Now, you've seen this language before, an array. What's the name of our first array, the female group of data? It's F. Let's go to our second array, and this array is called M. Now the third one is tails. What does this mean? We can either run a one-tailed test or a two-tailed test. If we're not sure if there's a difference or not, then we normally just run a two-tailed test. So the two-tailed distribution equals 2. So I put a number 2 right there. And then the type, it's either a paired sample t-test or an independent sample. Excel calls it a two-sample. And then there's also of equal variance or unequal variance. We're going to assume equal variance. So a paired sample t-test, that's if you have the same group of people, maybe at just a different time, or a two-sample t-test means two completely different groups of people. That's what we have, is a 2. So two-sample equal variance, we would type in the number 2. And then we click OK. And here, let me center this up again, and let's bring it down to the thousandths. This is our p-value, 0.049. So I'm going to put that right up here, 0.049. We're not going to interpret it yet. I'll wait until we get all three measurements done, all three tests done, and then we'll make some decisions. Now the third one is even simpler. Just go to any internet browser and type in Cohen's d effect size, and there are tons of calculators out there. I've already done it, so I'll save us a little time. It's 0.189. That's our Cohen's d effect size. And remember, our effect size says, okay, well, how big is that difference between the two groups? And our number is 0.189. Okay, I'm going to quickly pause the video again right here, and I'd like for you to calculate that p-value from the t-test. So simply use the insert function and type in t-test and then walk through the steps. The other thing you can do, it's completely up to you. If you do want to calculate your own effect size and go to the internet browser and type in Cohen's d calculator, you'll also need to know the standard deviation and the number of people in the sample. And you can get that right from the FX. STDEV, that's the standard deviation right there. And then you would just type in F for the female and M for the male. And then also the other one is count, C-O-U-N-T, to determine how many people are in each different group. So you can do that if you want, but I've already done it for you. So I'm going to go ahead and pause the video again, recreate what I've just done, creating finding the p-value from the t-test. Now, before we make our final determination on a research question by using our decision-making table, I want to throw in just a little bit of a bonus for you here. And oftentimes, it's very helpful to visualize our data in some way. In this case, we would just be visualizing the averages between the male and the female math final scores. To do that, super simple again, just highlight the cells that have the titles and the averages, go up to Insert, and we could click on Recommended Charts, but we know we're going to use a bar chart for this one. So we simply click, and then let's just use the very first one. Now, what you see here, actually, let's change this chart title. I did that. Let me do it again by clicking right there and then highlighting. And I'm going to change this to Math Final Scores, and then just click outside of the box here. So this is our data visualization of the difference between the female average and the male average math final scores. And if you take a look at this, it can be very misleading. We have to always be very mindful of our y-axis when we're doing bar charts. In this case, our minimum bound number is 9.4 and the maximum is 11. This number right down here should be 0. That will give us a better visual representation of the data. So to change that 9.4 to 0, just go anywhere along this y-axis and just click one time. Actually, double click. There we go. And it brings up a Format Axis box over on the right. You see where it says bounds and minimum 9.4? I'm going to highlight that and just change that to 0 and then X out of the box here. And this changes that minimum bound to 0, which is a better visual representation of the difference between the female and the male scores. Okay, that was just a little bonus. Now it's time to actually use our decision-making table to make a determination on our research question. I'll just state it one more time. Is there a difference in math achievement scores between the two groups that would warrant an intervention? So using the 3 tests, the very first one is our eyeball test. And again, each one of us is an expert in our own fields, looking at our own data. And as I look at the difference between 9.9 and 10.9, between the female and the male, yes, there is some difference, but in actuality, there really isn't a huge difference there. Not really. 9.9 and 10.9. Obviously, we'd want to continue to monitor to see if that gap gets bigger, or if the male scores begin to drop. So we want to see we have to keep on monitoring it. But at this point, 9.9 versus 10.9, looking at our bar chart, there really isn't a huge difference. So I'm going to say not really. Now, again, as we're moving along, here's our second test. Our p-value, and our criteria is 0.05 or below, and 0.049 is below 0.05. We interpret that to mean there is a statistically significant difference. Yes, there is a statistically significant difference between the two groups. Okay, that's what our analysis indicates, our statistical analysis. Now, with our Cohen's d effect size, it's calculated at 0.189. I have the calculator, or the way to interpret it right here. And if it's around a 0.2, that's a very small effect size. ES stands for effect size. Cohen would characterize this as it's difficult to detect a difference there. If it's anywhere around 0.5, it's noticeable. Maybe the difference is noticeable to the naked eye. Or if it's 0.8, around 0.8 or above, it would be a grossly perceptible difference. And so how would you interpret 0.8189? Yeah, it's really difficult to detect a difference. Okay, so there we have it. With the decision-making table, what we want is that all three of these different types of measurements would be consistent. And what we have here is really an inconsistent interpretation between a difference. Our eyeball says it's not really a difference. Our Cohen's d says that it's very difficult to detect the difference. The only one that does stand out and says, yes, there's a statistically significant difference is our actual p-value from our t-test. So the answer to this question, from my judgment, would be there really isn't a difference in math achievement scores between the two groups that would warrant an intervention. I sure hope that using this decision-making table and looking at our research question, you were able to determine yourself, as I was going along and in making those interpretations. I sure hope you were able to make those determinations as well. Blessings.